Since the introduction of vaccines in 1796, the US alone has seen an overwhelming decrease in the rate of infectious diseases such as hepatitis A, mumps, measles, and diphtheria, to name a few. But how do vaccines help protect your body against these infectious diseases? Vaccines directly work with your innate and adaptive immune system in order to create a memory response that will allow your body to be protected if ever encountered by these foreign bacteria. When your body is invaded by a foreign infectious bacterium, the innate immune system is the body's first line of defense. Leukocytes such as basophils, eosinophils, and neutrophils act as a barrier to prevent entry of invaders or limit their spread. The pathogenic bacterium can then be captured by antigen-presenting cells, such as dendritic cells and macrophages, which present these antigens to naive T cells. In the adaptive immune system, the B cells and antibodies compose humoral immunity or antibody-mediated immunity, whereas T cells compose cell-mediated immunity. The exposure to antigen will stimulate the B cells to proliferate, where they will then begin to produce and release antibodies specific for the antigen. These antibodies bind to the antigen, marking it for destruction or to prevent further action of the pathogen. When antigen-presenting cells such as dendritic cells present the antigen to the T cells, they become activated and can differentiate into many subsets that have various roles in the immune system. Killer T cells are also generated, which find and destroy the invader. When the body is first introduced to a new infection, it takes time for the adaptive immune system to respond to it, and in some cases, even a few days can be too late. There are 4 general types of vaccines, which include live attenuated, inactivated or killed, toxoid, and subunit vaccines. Inactivated vaccines use the killed or inactive version of the pathogen. These vaccines prevent against infectious diseases such as hepatitis A, influenza virus, rabies, and polio. Since these vaccines are not alive, they are unable to replicate within the host body. This is able to produce a humoral immune response, but not as much of a cell-mediated response. Since the humoral response is weaker, booster vaccines are required for extended protection. Subunit vaccines use specific pieces of the pathogen, such as the surface proteins. These vaccines protect against HPV, shingles, pneumococcal disease, and hepatitis B. The specific pieces of the pathogen allow for a strong immune response, including humoral and cell-mediated immunity. However, like inactivated vaccines, they are also short-lived. Toxoid vaccines use toxins that are produced by certain bacteria to act as the antigen. Toxoid vaccines protect against tetanus and diphtheria, as the infectious diseases are caused by the toxins released and not the actual pathogen. These vaccines elicit a strong immune response and are known to be very safe, as they are unable to cause the infectious disease they protect against. Live attenuated vaccines contain a small amount of the weakened live pathogen. These vaccines protect against measles, mumps, rotavirus, and chickenpox. This reduces the virulence, but also still allows the body to recognize the foreign bacteria. These vaccines are not recommended for people with weakened immune systems or long-term health problems, as it may cause illness. Scientists are still working to create new vaccines to continue to help protect against many infectious diseases.